So we're going to continue on with our section on factoring. So let's take a second and factor this expression, 4x squared plus 12x minus 16. Okay? The first thing that I notice and that you need to start paying attention to and looking for is that there's a common factor. Okay? All of these numbers, 4, 12, and 16, are all multiples of 4. So I can take out a common factor of 4 as a GCF, and that will leave behind an x squared plus 3x and minus 4. Okay? So number 1 is always going to be, look for GCF. Okay? Second step is, can the remaining expression be factored? Okay. So can we factor x squared plus 3x minus 4? Is there anything that multiplies to negative 4 but adds up to 3? And the answer is yes. So that would be x plus 4 and x minus 1. And now what we have here is an expression that we would say is completely factored. So here we talk about factoring. To factor a polynomial completely, first factor out the GCF of the polynomial's terms. Then factor the remaining polynomial. That's what we talked about with 1 and 2. Find the GCF first, then see if what's remaining can be factored. Okay. So if we look at example 1 here, what is the factored form of 18x squared minus 33x plus 12? Well, is there anything that's a common factor of 18, 33, and 12? And the answer there would be 3. So if I were to factor out a 3, I would be left with 6x squared minus 11x plus 4. And now we look at this remaining quadratic and we try to factor that. Well, it's got a leading coefficient greater than 1. So I'm going to go ahead and I'm going to multiply my a times c and get 24. And what multiplies to 24 but adds up to negative 11 would be negative 8 and negative 3. So my 3 just gets carried along now. I've got 6x squared. I'm going to break my minus 11 into minus 8x and minus 3x. And then I'm going to look at my grouping. I'm going to look at the first 2 as a group, and remember I'm going to look at the second 2. So I have 3 times 6x squared minus 8 has a common factor of 2x, which would leave behind a 3x minus 4. And the only thing I could divide 3 and 4 by would be 1, leaving another factor of 3x, not minus 4. If I take a positive divided by a negative, then this should be 3x minus 4. So now what I'm looking at is I've still got the 3. And now when I look inside of this group here, I see again there's that common factor of 3x minus 4. And when I pull the 3x minus 4 away, I'm left with a 2x minus 1. And there is going to be my completely factored form of 18x squared minus 33x plus 12. Okay, so let's look at another one. 8x squared minus 36x minus 20. So what is there that I can divide out of 8, 36, and 20? Well, I could take out a common factor of 4. And that'll leave me with 2x squared minus 9x and minus 5. And now I'm again going to take my a times c, which gives me negative 10. And if I take positive 10 and negative 1, that signs are backwards there. So I need negative 10 and positive 1 to multiply to negative 10, but add up to negative 9. So now I'm going to go through and I'm going to split my minus 9x into minus 10x plus x minus 5. And then I'm going to, again, group. I can factor out a 2x from the first group, okay, leaving me with an x minus 5. The only thing I can divide out of 1x and minus 5 would be a positive 1, leaving an x minus 5. So I've got a factor of 4. I've got a common factor of x minus 5. And I'd be left with a 2x plus 1. And there is my completely factored form. Okay. So let's go through the same steps and see, is there a common factor in these terms? Okay. I believe we could factor a 3 out of everything, and that would leave me with 2s squared. 57 divided by 3 would be 19s, plus 72 divided by 3, which is 24. So then the next step is to take a times c, which gives me 48. And I need two numbers that multiply to 48, but add up to 19. And those are going to be 16 and 3. So I've got 3 times 2s squared plus 16s plus 3s plus 24. Okay. And now I'm going to factor by grouping. Group the first 2, group the second 2. So I can factor out a 2s from the first group, leaving an s plus 8. I could factor a 3 from the second group, leaving an s plus 8. So I've got the 3. My common factor in my groups is the s plus 8. And what's left over is the 2s and the plus 3. And there is my completely factored form. Okay. Example, 20w squared minus 45w plus 10. So what is there that I could divide 20, 45, and 10 by? Well, let's try 5. That would leave me with 4w squared minus 9w and plus 2. So now I'm going to factor the inside. I'm going to take a times c, which is going to give me 8. And what multiplies to 8 but adds up to negative 9 is going to be negative 1 and negative 8. So now I have 5 times 4w squared. I'm going to make it minus w minus 8w plus 2. So splitting that 9 again. And now we're going to group. So when I group, I can take a w, which leaves 4w minus 1. I can factor out a 2, which leaves 4w and minus 1, because 2 divided by negative 2 is negative 1. So I've got a 5. My common factor inside is the 4w minus 1. And what's left behind is the w minus 2. And there's my completely factored form. So remember, whenever we're going to be factoring, or later on when we're going to be solving using this factoring method, number 1 is to look for the GCF. Once I take the GCF out, I look at what's remaining and I factor what's remaining behind. Okay? We'll practice tomorrow in class some more. We'll see you then.